Okay, hello class. We're done with factorization and we'll be entering into completing the square method. Now, I noticed that most students are not very familiar with completing the square. So I'll tell you why we use completing the square and okay, let's start with that. So why do we use completing the square? Completing the square came about because of we noticed that factorization could not solve every kind of quadratic equation or expression. Like for instance, let me give you an equation. Let's look at this question here. 2x squared plus 3x minus 8 is equal to 0. Now, remember in factorization, we know that a quadratic equation is any equation that's of this form: ax squared plus bx, this is the general form, plus c is equal to 0. Now, if we're working with factorization to solve this question, we'll know that first of all we need to find what is our AC, and our AC will be what? Minus 8 times 2, which is equal to minus 16. Our B is equal to plus 3, right? So we know what we do. We usually find two values that when we add them, we get B, and when we multiply them, we get AC, right? Now, pause and think of these two values. Have you found any? Now notice something. There are no two values that can give you this particular solving. So we cannot find any two value that when we add them we get B, and when we multiply them we get AC. You can try it out again and see if there's any. There's none. Actually, the only two the values we can get here to add that when we multiply we get AC are only just 4 times 4, 16 times 1, what again? Okay, 8 times 2, and I think that's all. Now these are the only values, and when we multiply them we get AC. And notice something: if we're to add any of these two values, maybe either putting plus or minus, there's no way we can ever get 3. No way. No mathematical correct way can ever give you 3. So therefore we had to invent a new method called completing the square. Now in completing the square, we try to form a new square out of the equation that they gave to us. So we'll solve back this question again using completing the square method, and I'll show you the step-by-step method in solving using completing the square. Okay, so let's wipe the board clean and start afresh. So let's take out this part and then we can continue. Okay, now in completing the square, I'll tell you the first method, the first step, sorry, the first step. So first step, step 1. Step 1 is to do what? Make sure your A is unity. So make sure A is unity. So let me space that out. It was not spaced well enough. Okay, so it's make sure A is unity. Now what is unity? Unity means 1. So what is our A value here? Our A value is what? Sorry, let me change that. Our A value is 2, right? So how do you make 2 unity? You just divide through by 2 and to give you 1. But remember, in mathematics, whenever you are bringing in any new operation, it must go for every other place. It must go for both the left hand side and the right hand side. So how do we make sure that A is unity? We divide through. So I can say that let us divide through by 2. So that will be what? 2x squared plus 3x minus 8 is equal to 0, and then we divide through by what? 2. So divided by 2, divided by 2, divided by 2, divided by 2. It is going for all sides. Therefore what happens here? 2 can cancel out 2 here, 3 cannot cancel out 2, but 8 can cancel out 2, and here becomes 4. So what do we have? Our new equation gives us what? X squared plus 3 over 2x minus 4 is equal to 0, because 0 over 2 is 0. Now what's the next step? The next step now, step 2. The next step is that we take our C to the other side. So we take, or let's just say, mathematically it is not just take C to the other side, it's actually called subtract C from both sides. So let's use the mathematical term. Or now if you want to take C to the other side, I can just say add C to both sides so that it will cancel out here. So let me just use the mathematical way of writing it. So it will be what? Add C to both sides. So what would that become? Let me draw my line. that will be, if we were to add c both sides, what's our c? Our c value is -4. So our c value is -4. So if I were to add, okay, I think that will not be, that will be subtract c. So please let me change that to subtract c. So this will be subtract c. So let me just say minus c rather than, since there's no space, let me use the word minus. Minus c to from both sides. Add so it is from both sides, not to both sides. So okay, that's from. Please forgive me. So it is minus c from both sides. So if we're to minus c from both sides, notice that if our c was -4 and then we're to minus it again, we just put minus c, right? And that becomes minus times minus, and that gives us +4, right? So it's like saying we're adding c to both sides. We're adding +4 to both sides. So that will be x squared plus 3/2x minus 4 plus 4 is equal to 0 plus 4, and that will give us what? X squared plus 3/2x is equal to 4, because this entirely cancels out. Is that okay? So in other sense, I would have just told you easily cross this one over to this way. That would have just been an easy way, but I just felt like let me just follow it mathematically how it's meant to be written down. Now what's the next step? Now this is a very important step. Step 3. Listen, it's going to be what? You take the half of b, so take the half of b, that's the first thing, square it and add to both sides. Now remember, when we say both sides, it means both the left hand side, which is here, and the right hand side, which is here. Okay, so let's do that. Now what is our b? Our b value is equal to, okay, so let me use a different color to write that. Our b value is equal to what? 3/2, right? So what's the half of b? The half of b is equal to, like saying 3/2 multiplying 1/2, right? And that will give us what? 3/4. Now what's the next thing? We take the square of that half of b. So taking the square of the half of b, what do we have? We have 3/4 square, right? So we take the b, take the half of b, and then we square it, and then we do what? Add it to both sides. So we're adding this value that we've gotten here to this side and this side. So that will be what? We have our new equation as x squared plus 3/2x, then adding the new values that we have, it is 3/4 squared is equal to 4 plus 3 over, I know my face is blocking that part now, but I will shift it out so you see what happens. So it is this, sit here, we added plus, so let me use my marker to do that well. Okay, so let me clean everything there. So that is plus 3/4 squared. So we added it to both sides. Okay, so let me separate these and let's continue. So let me still push this over. That's too much. Okay, so now that we're done with that, what's now the next thing we do? We now complete the square. That's what is called completing the square. So finally, we're now down to what the topic is all about, completing the square. Now notice something. When you were in school, you've heard about, they taught you expansion of algebraic expressions, and they gave you a very, very simple expression that looks like this: a plus b, and they said square. And what did it give you? It gave you a square plus 2ab plus b square, right? Now if I was to write this right hand side value, I can write it back as this, right? That's because of this is just the this is now the opened expression, but this is the square of, this is the squared value. So this was the squared value that when they opened it, when they expanded this bracket, they got this. That is exactly what's happening here. Look at this. We're having x squared plus 3/2x plus 3/4x 4x power 2. This almost looks like this, or it actually looks like this, but only that it's now having different values. So what happens here? We are going to complete this particular value that we've gotten. We'll complete the square here now by transforming it back to this left hand side. So that's what completing the square is all about. It tries to complete this full square by introducing new value terms that when we now work with it, it will always give you this kind of value, so that even when you expand it, you get back this. Is that okay? I believe I'm speaking what you can understand. So okay, let me just give a recap. So that's this one now is out of the question, but I want to just explain what's going to happen here. So if I pick this new value and I try to complete this square, we have x squared plus 3 over 2x plus 3 over 4 raised power 2. I just like how this one looks like, I pick the first one, which is x squared, and I pick it as x, and I say plus. That's why it must always be unity, so it can be easily defined. So this is x, and what was the c part? Just like this one, the c part was what? B. So the c part is what? 3 over 4. You leave the square, so we have 3 over 4, and we put it as what? Square. And that's it. But just to show you that we know what we are doing, let us try to expand this, and we'll see we'll get back to this value. So expanding this, we have what? Let's say x, will open the first bracket. I have to take it step by step now. Plus 3 over 4. I believe you understand this. This is elementary expansion. Okay, so what happens here? So x multiply x, right? That's x squared. X multiply 3 over 4. That's 3 over 4x. Then 3 over 4 multiply x. That's still 3 over 4x. And then plus 3 over 4 multiply 3 over 4. And that's like saying 3 over 4 squared. You can still open the squared if you like, which we might not do right now, but we'll do it later on. So now 3 over 4x plus 3 over 4x, since they are like terms, they can add each other up, and that will be x squared plus, since their denominators are the same, you pick one denominator, and here is 3 plus 3, 6x plus 3 over 4 squared x. Are we done? No, we can divide this through. So 6 can cancel out 4. That's 2 can cancel out 6, and 2 can cancel out 4, and that will be x squared plus 3 over 2x plus 3 over 4 raised power of 2. And we are back to here. Is that okay? So you see that this and this are the same thing. So we just try to now put this one in the full completed squared symbol. So that's what we're going to do. So I'm wiping off this part of this board. It's just for analysis. So let me take it off, and then we continue from where we stopped at. Okay, so let's continue. So take out this. So even this one as well, we don't need this as well in our solving. So taking it out and continue from where we are. So we complete the square, and that will become what? X, sorry, I want to use my black. That's x plus 3 over 4. So we've completed the square, is equal to 4 plus, now I can open this. This will give me what? If 3 raised power 2 is 9, 4 raised power 2 is what? 16. So that's 9 over 16. And if I also add these two together, I think it will give me a value. So let me just use my calculator so I won't waste much time. So I think I have my calculator already saved here. So I can just say 9 over 16. Let me see. 9 over 16. 9 divided by 16. That gives me this. Then let me not use that. I want to leave it in fraction. So using fraction, I know that in fraction here is over 1, right? So the LCM is 16. If I'm the LCM is 16, so we do 16 divided by 1 is 16. 16 times 4 will be giving us, I think it's around 64. Yeah, 64. Plus 16 divided by 16 is 1 times 9, that is 9. So 64 plus 9 is 73 over 16. So that's it. Okay, so I didn't need my calculator after all. So let's continue. That's x plus 3 over 4 squared is equal to 73 over 16. So now what can we do next? To take away this raised power 2. Remember, what this completing square helps us to do is that it gives us only one value of x now, no longer two values like how we're having here. So we have one value of x, which is easier to work with. So but how do we make x instead of formula? We're having a squared here. So to make x instead of formula, we take away this squared. And how do we take away this squared? We take the square root of both sides, right? So I can write it out here, take square root of both sides, take square roots. And that will give us what? X plus 3 over 4, because the square root will cancel out the square, is equal to, remember when you're taking the square roots from a squared value, remember, what do? You put your what? Plus or minus. So that'll be what? Plus or minus 73 over 16. And because of the surd form, I know that you can put this as plus or minus 73 over surd 16, or square root of 73 over square root of 16. So square roots can break down for each term, since according to the rules in surd, so it works well. So I write that what? X plus 3 over 4 is equal to the plus or minus 73 over what's the square root of 16? That's 4, right? Yeah. So I can take my 3 over 4 over to the other side so my x can become the subject of my formula, and that is x is equal to, when plus 3 over 4 goes over, it becomes minus 3 over 4, so that's minus 3 over 4 plus or minus square root of 73 over 4. Okay, let me move my screen a little bit over this way so I can continue. And then I draw my long line, and I can write now that my x is equal to, now since it's 4 and 4, you can pick one LCM. You can pick the LCM, so that's minus 3 plus or minus 73, square root of 73. And I'm almost done. I can now say that x is equal to minus 3 plus root square root of 73 over 4, or minus 3 minus square root of 73 over 4. And I'm done. But if my answer was required to be in decimal, then I might need to also use my calculator to get what is the square root of 73, add it with minus 3 and divide by 4. But for now I can just stop here. But if you feel like, you can go the long way of finding it using your calculator to see what the actual values might look like. So, but nonetheless, this is where we can stop at. So let me just recap on every step I took for completing the square method. Every step I took: number one, make sure A is a unity. So if they give you a value and A is not a unity, you make sure it is a unity. And how do you make sure? You divide through by that value of A all sides. So if here is 2, we divide through by what? 2. So 2 divide 2, 3 divide 2, 8 divide 2, 0 divide 2. Do it everywhere. So next part, we minus the C value from both sides. Our C value finally became minus 4, so we minus it from both sides, and we got x squared plus 3 over x is 3 over 2x is equal to 4. Then what's the next step? We take the half of b, square it, and add to both sides. So what's the half of b? Our b is 3 over 2. Taking the half of b, we got 3 over 4, and then we squared it by having 3 over 4 raised power 2, and then we added it to both sides by having x squared plus 3 over 2x plus 3 over 4 raised power 2 is equal to 4 plus 3 over 4 raised power 2, added it both sides. Now what's the next step we then did? Then we start talking with steps. We only now completed the square. So we completed the square from here. From this, we completed the square. So in case they ask you a question and they give you something that looks like this particular value, let's say x squared plus 3 over 2x, and they say please complete the square, like I've seen questions that appear like that in your WAEC. They might give you something of this nature. Let's say let me just give any kind of value. They might give you x plus 5x, and they say complete this square. How do you complete this square? It says equal to, let's say they say is equal to 2, and they say complete this square. They say is equal to 0. How do you complete this square? That's what we just showed you here. You take here's your b, right? So you take the half of b, then you square it and add it to both sides, and that's how you complete your square. Okay, so that is just by the side. That's just by the side. So we might maybe work on questions that look like that as we go along. So what's the next thing we did? After taking the square, after completing the square, then we took square root and finally solved it until we got the two values of our x, which was this and this. So that's it about completing the square. Maybe I'll take some more examples in our next video, but this is just a full preview on everything to know about completing the square. Then other ones we'll be taking as examples. We'll just go right into the solving. I'll talk less and we'll do more solvings quickly. Thank you.